I'm going to try to do a little bit of an audience participation thing here. So this is a code for Slido, slide.do. You can either scan it or do 1442698 is the event code. I'll have one place where I actually go ask a directed question, but there's also a way to submit audience questions as you go. Time permitting, at the end, I'll bring up the questions list and we'll take anything that comes up. One reason I like doing this is you can vote on questions. So if you see somebody else's question that you also want to address or discuss, then you can upvote that. So we can use these questions both as anything that you'd want to ask me, but also it might be fun to see anything you'd want to sort of ask the room, anyone else here. Has everyone who wants to get the link gotten it? All right, so now back down to business. So who's heard about ChatGPT? All right, it kind of took over everyone's social media and news got into it and everything. But really, 2022 overall was the year of generative AI. So we started with, early on in the year, there was all kinds of work in images. So all kinds of companies were working in this, like Google's Imagen. They didn't release it publicly, but DALL-E, OpenAI, was a public release, and so everybody's been playing with that for generating images. In fact, it's come a long way in the past, 6 or so years. Back in 2014, we were happy to generate a blurry thing that sort of vaguely looked like a face, all the way into 2022, when we can have a dog in a sushi bun house by just describing that in words, and it generates it, and cool. So technology's come a long way in that time. Just preview a couple years down the road, think where we're going to be. So it was also, we saw ChatGPT as a language or text generator. There's been equally good work in code. So here we see GitHub Codex. Anyone used GitHub Codex in their work, or any other code completion kind of models? Okay, maybe I'll demo something at the end here. If you're writing code by hand and having to look up documentations and tutorials, you might have to change what you're doing tomorrow. So in one example is AlphaCode. So this was a work by DeepMind, published in the journal Science in October. And actually, no, this was December. This is a code model that can compete with programming competition level coding. So not just the kind of things that you can go look up on Stack Overflow or GitHub, but actually generating new kinds of algorithms and trying them out and making sure things work. You've probably gotten one of these kind of things in your face from your phone or whatnot, where as you're typing, it will give you a phrase suggestion. This was actually my dissertation work to study how these things work and what they do to people. But right now, the current technology that you're seeing out there is pretty generic niceties and such. I think by the end of the talk today, you'll be very surprised that it's not yet that much better. It will be really soon. Lest you think this is just like on-screen kind of things, Google also in December released a robot transformer using some of the same models and mathematical approaches that were used for this for the language and image things, to do navigation and operation of robots in real uncontrolled environments. So here is this multitask robot that's able to move around, do things in a kitchen, take things out of drawers, go look for something and find it and put it somewhere else, all given just a description of what task it's supposed to do. Go get the Coke bottle out of the fridge and put it on the cabinet. So, and finally, let's see if this loads up here. but we've got some audio
Nay,
examples.
lording, answered Wolf. We know not how to
So
call you
on the
lord or lady.
left side, you'll see
We have
the
lived too
prompt,
long in the
what it
forest,
was given,
and are
then
now.
as it
Our first
goes over
impressions
the
of people
line,
are,
that's
in
completed.
9 cases out of 10, mere spectacle reflections of the actuality of things. But they are impressions of something different and more.
Prompt. AI generated.
Nay.
Sorry. Okay, thanks. So we're seeing that there's all kinds of advances in all different modalities. And it's not just OpenAI who made ChatGPT. There's a lot of different players in this space. It's both OpenAI, for example, was founded in 2015 as a nonprofit with a goal of figuring out how to develop AI safety, like aligning AI's goals with human goals. And they were doing a lot of early work in robotics, and as you might have been able to tell, they've drifted some since then, especially on the open part and the nonprofit part. Google and DeepMind pioneered the original transformer model, and they've been doing a lot of the work, like AlphaGo that beat the world Go champion, AlphaFold for protein folding, that's really revolutionizing biology now, AlphaCode. They have a lot of good models internally, probably some stuff that's better than ChatGPT, but since they are a big company with a search business, they were a little more reluctant than a little startup like OpenAI to put their stuff out there. Facebook and Meta and Microsoft, Allen Institute are all other companies that are playing in this space and doing both the fundamental research and a lot of applications, training big models and showing off their work. I'll highlight Hugging Face later, but they do open collaboration, academic and industry working together. So this isn't all in industry, but unlike a lot of previous technology advances, industry really has been leading a lot of this simply because of the scale, and we'll get more into that. Actually, let's switch this over to the Slido thing. I want to do a first, where's my pointer? There we go. So this is, play the word cloud, please. All right, so what one or two words come to mind when you think of an AI like ChatGPT or DALL-E? So we got a wide range of sentiments coming up here, all the way from kind of the impressive and groundbreaking and cool to the scary and cheating and magic Q&A, goodbye creativity, Skynet. So a wide range of sentiments in here. And I think this is reflective of what we're seeing in the news and in the wider world. And maybe it's the very fact that it is powerful and impressive and cool that also makes it scary in some ways. So efficient, fast, search. Yeah, we'll come back to search. I think that's a key idea for understanding how these things go. All right, so let's see if I can do this. Let's do another one. So if we start thinking about how might these things actually work, I want to poll what your intuition is already. I realize probably not many of you have studied the details of how it works, but like kind of what's your intuition? What kind of thing is it like? Results for a moment here. So a lot of machine learning, regurgitation, if-then coding, text classification, predictive analytics. Okay, so by human replacement, do you mean that there's probably some people who are just typing really fast and pretending that there's an AI system, but it's actually just the mechanical Turk who's doing the work? So fortunately for the humans involved, that is not actually true, although that there was a lot of human work involved in training these models, but maybe not where you're thinking. It's not about if-then coding, like embedding knowledge of here is exactly what to do in this situation. It's more like a vast corpus. That there's a lot of examples of what happens in different kinds of situations that we can take data from everywhere and basically do statistics. Self-learning, yep, a lot of math. Yeah, there's a few things that make me want to talk more in detail about some of this with some of you. If you're thinking about the details of like Bayesian and neural nets and stuff, then we'll talk more afterwards. Okay, so let's switch back to slides and talk about how this thing actually works. But first, we might want to ask, why should we care? So I think we have a few reasons to care, even if we're not the people developing the technology, and that's fine. All of us are very soon going to be using the technology, whether directly, like it's going to be offering predictions on our phone or generating images for our presentations or whatnot, or we're going to be using the technology as part of our business and creativity and making products and such built on it. I think if we understand how it works, we'll be able to use it better. Not just take it as it is, but be able to make it more reliable for the things that it does work well, and be more creative in making it do new things that it couldn't do before. We'll have better attitudes about the system itself and the results that we see from it. For example, all these things are built on a lot of human effort. Both the original training data that they're built on and the fine-tuning and development that goes into each individual model. So I think we can practice gratitude, which is a virtue there, in a way that we can't if we're just taking the model as this black box that's spitting out answers at us. It'll also give us more humility about knowing its limitations. It's easy to say, oh, it can do everything, or bemoan that it is taking over everything. But we can be humble and say, here's what it's actually good for, and here's maybe what it's not. Even if it might look like it's good for this, actually maybe it's not. And finally, I think we need to be thinking about other people, not just about ourselves and protecting our jobs from it, but we need to be aware of how these systems are going to be affecting people who aren't like us, people whose lives are going to be affected by the decisions that are shaped by these models. So we can be more aware of the biases these models have, and also be able to regulate its excesses. These models are extremely data hungry, so we're thinking about questions of privacy, things like that. 1 second. Plug in. So I'll give a preview of where I think so I said ChatGPT isn't magic, but it is doing something pretty cool. Where is the magic? And briefly, the magic is language in community. And here I'm basing on some ideas that come up in the very beginning of the Bible, when God said, let there be light. I don't know what you all think about Genesis and its reliability, but you probably have heard of that phrase, let there be light. But what comes before that is God said. And then later when it talks about how people are created in God's image, most of what we know is that God said. So like what it means for us to be in God's image is at least in part related to language. So there's something almost magic about language for creating and understanding and shaping things. But the very first thing that God said was not good was for a human to be alone, for there to be only one language-empowered co-creator being on the earth. So it is language is intended to be used in community and relationships. So we get the power of something like ChatGPT coming from people using language, all kinds of language, in the huge community that we now call the internet. So there's the magic. Come back to this if you're interested in how that works out linguistically. So let's talk about generative models. So first thing to be aware of, even the major news outlets get this wrong. The acronym is Generative Pre-Training, not GTP, GPT. And this might seem like this is the label of, or the name of some of the algorithms that, for example, OpenAI puts out, but it's not exclusive to OpenAI. All of this, all of the players in this field are using approaches like this. So to get a sense for how this works, we're going to play a little prediction game. I have written up here a couple of sentences from a book, and you're supposed to guess what this word is right here. I won't ask anyone to call it out, but actually start thinking what word could go there. Any ideas? Probably not many good ideas. But if I told you that it's after A, now do you have a little more idea? What do you think? What kind of word might go there? Nouns, maybe not just any noun, but it's got to start with a consonant. So even just one letter of context gave us a clue that maybe it's a noun or a noun phrase. And we can make things that start with A in other ways, but likely we're thinking probably a noun, almost definitely something that starts with a consonant. So now I give you one more word. It's on A. Does that give you any more clues what this might be? So maybe it's some kind of, well, it's something that makes sense to be on. Maybe it's a location, but location doesn't quite get it right, because you can be on some other things too. All right, so on something. So those are clues coming from right before that word. One of the big advances in the underlying technology that was used to make these models now is one that lets us look at contextual information from far before this. So I'll tell you that this is 3 lines out of a book, and they even rhyme, and the one above it is goat. So half of you are wondering, what book is this? And some of you might know it already, but at least what that's telling us, this probably ends with a oat sound, but knowing how rhyming works is probably not the same word again. But even with these 3 little clues, we're already pretty much narrowing in on a small set of words. Any guesses? Boat? Any others? Float, maybe? Which do you think is more likely, goat or float?
Is it 5 letters in the word, or?
Oh, I didn't mean for the question marks to match up with letters. Sorry, yeah.
I said both.
Yes. Okay, so, but you're thinking there is a couple of possibilities here, and you're able to judge which ones are likely and which ones are not. This is demonstrating good linguistic competence, that you're not just able to make one guess, you're able to make a whole distribution of guesses and say this is probably more likely than that, and other clues that's giving it to you. So you are fairly good at language, maybe not good at this particular isolated task, but generally pretty good at language, and so you're able to make this guess pretty well. And it turns out that now you start to Maybe some of you know this book. This one right here, where we know it's a children's book. Particular, could you, would you with a goat? I would not, could not with a goat, says Guy in Green Eggs and Ham. Would you, could you on a boat? Well, what do you think comes next after that? So let's keep going. So try guessing what the next word would be after it comes after these words. So this is going to come at you a little fast, so you're not going to be able to blurt it out. But just as you see words, try to think, what might the next word be? It'll come fast. You ready? 1, 2, 3. Yeah. So, easy, hard, somewhere in between, unusual? Which ones were easy for you?
The response lines.
The response ones. I could not, would not. Well, it's not exactly the same as I would not, could not. Maybe he's switching it around a little bit. But I will not with a. So some of linguistic competence involves knowing when to go back and copy, say the same thing again. Some of it involves like relationships between words, rhyming and things. Some of it involves syntactic relations, like our A follows, or a word after an A has to start with a consonant, that kind of thing. So it turns out that, that this idea of just predict the next word actually requires many skills. So the name for this broadly is language modeling. And more specifically, this is sometimes called autoregressive or causal. Just we're doing it one word at a time. And to do it well, we need to know about sentence structure, verb and noun agreement, numbers and object and semantics, like what kind of things typically go together, what kind of words can be locations that you can be on, what typically happens next in stories, like a silly children's story, or more advanced stories, like how movies generally work. You might kind of be able to expect the kind of thing that happens next because we're in a movie that's like this. You can extend this idea to math, like if you're predicting the next word in a worked math problem, that embeds a lot of idea of how to solve problems as well as what particular numbers to do. It even captures things that you might not think are language modeling, like summarization. If you read a big long thing and then there's a TLDR or in short, comma, the thing that comes after that, if you're good at guessing that, you're good at summarizing a long document. It even turns out that even if you don't make any special attempt to collect a parallel corpus of sentences in different languages, you can find examples of translations just in natural text. I'm not the cleverest in the world, but like they say in French, je ne sais pas une bêtise. So that gives you a rough translation, even if it's not word for word. Or actually, the square bracket there was a exact translation. I don't speak French, but something like that. So this was an example from the paper by OpenAI in 2018 that introduced the GPT-2 model that said, or asserted, language models are unsupervised multitask learners. Unsupervised meaning it doesn't have to be labeled with this is a translation of that. You just find examples in the open internet. And multitask meaning it can do all kinds of things like translation without even having to be told what tasks to do. So that's a rough idea of how these might work, but how might we actually learn how to do this? So how do we learn from a mistake? So let's say that the model was reading this text and it ended up saying, would you, could you on a horse? And we say, no, that was actually boat. So what could we learn from knowing that it's boat and not horse? Well, remember our context clues. we learned something about the ends with oat sound. Whatever that clue was, if whatever our representation for that was too close to idea for horse. So when we queried for that, we got horse, and we shouldn't have. So we can refine that contextual concept, and we can also refine what each individual word is like. So we ended up with horse, but we shouldn't have. So that probably meant that horse was, in a sense, too close, too aligned with that concept. I'll get into the details of that in a moment, but just note that we can learn something about the context, the word that we incorrectly guessed, and also the word that we should have guessed. Goat should have been more similar to whatever this context is. So each individual word gives us a lot of additional information to use to train this model. So it might be good to just step back a moment. Many of you know about machine learning, but I'll just give a brief overview of how this is different. So many times when you think about writing a program, you think about there's some input that goes into a computation, and you had to code up that computation. You write up a bunch of tens of thousands of lines of code about what exact logic to do, and it gets your output. Machine learning is still doing some computation. The details of the computation structure might look different, but the whole point is that instead of you hand coding that computation, what you give it is you code up a learning algorithm and give it input-output pairs. For this situation, here's what output you should give. And then the learning algorithm generates the computation that's going to be used for generating your outputs. But nowadays, now that we have the internet, you can do something even better than that, which is take the whole internet, or a large set of training data, without labels, just the data, like we saw with green eggs and ham. We just give it to a model for pre-training, and then it already knows a lot about how language generally works. So when we give it more input-output pairs, like label the sentiment of this sentence or whatever, it doesn't have to learn English and then learn your task. It can just learn your task, which is a much easier problem. So this idea is that instead of having to label a lot of data, maybe you only have to label a little bit of data. So because you've already pre-trained on a huge amount of background information. So let's peel back the covers of this process a little bit. First thing we need to, it's basically a 3-step recipe. First, collect an enormous data set. Yeah, I mean, anyone can do that in this evening, right? Collect the whole internet on your laptop? Well, didn't say these were easy steps, but they're fairly straightforward mathematically, and you could imagine actually doing this. It's just doing it at scale that tends to be, well, worth the billions of dollars. So collect an enormous data set, and train an enormous model to be unsurprised by that data. And then ChatGPT's innovation, tweak that model from feedback. So let's just go one by one through that. So first is collect an enormous data set. I think a lot of people don't really realize just how enormous the internet is. So I'll give a couple of examples of some tasks that I asked ChatGPT, or its cousin model, to do. And then we'll see where those came from. So I asked it to explain generative pre-training, and it spat out generative pre-training is a type of machine learning technique that uses generative models to learn representations of data that can then be used to initialize the weights of a deep neural network, etc. I mean, it's right, but I don't need to show this to you, because you can just ask ChatGPT to generate this for you, and it will. So presentations are about to change, because you can just look up the answers to any question you might have. Anyway, point being, so let's tell it to write that in a tabloid style. Revolutionary machine learning technology is here to make your data dreams come true. Or write that in Shakespeare style. 'Tis a method most wondrous of learning most grand, where a generative model is used to understand the data of the world, ere it be labeled and planned. So you might notice this last thing, that, in many tasks, it doesn't actually rhyme. So I asked the model for what were your alternatives there, and I'm sorry, this is kind of too small to read, but it generated tasks when it could have generated A instead, so I went back and edited it, which you can do if you know how the models work. I said, actually, make a neural network in many, and then I said, what would you generate after many a chance? Or it could have many a task. Okay, those are maybe a little bit better. So if you can actually go in there and tweak how the model actually generates. I can demo stuff afterwards if you're interested in how these things work. But the point being, it seems like these are kind of unusual things. Where would we find an example of someone explaining the newest kind of deep learning model in Shakespeare style? We're certainly not going to find that in the corpus of Shakespeare, are we? Well, the internet is huge. There's lots of examples of even unusual tasks. In fact, just search Google how to talk like Yoda, pirate, Shakespeare, whatever. You'll get lots of examples of these things. There's Reddit is a great source of a lot of these writing prompts on anything, or constructed languages about weird ways of putting together words. Stack Exchange, world building. What if you had this weird situation? Or finding an idiom for a particular way of explaining things. There's just lots of examples of even the strangest things on the internet. So GPT was trained on some 300 billion tokens. A token is roughly a part of a word. And the model from DeepMind is trained on 1.7 trillion. In that data set, you're likely to find lots of examples of things that, aren't exactly the thing you're trying to do, but pretty close, right? So lots of examples of what Shakespeare talks like, or what tabloid headlines look like. Or Explain Like I'm 5, Reddit. Just lots of examples of stuff out there. So when you see something that looks impressive, like somebody asked ChatGPT to write a biblical verse in the style of the King James Bible explaining how to remove a peanut butter sandwich from a VCR. And it spits out something like, and it came to pass that a man was troubled by a peanut butter sandwich. And he cried out to the Lord, saying, "Oh Lord, how can I remove the sandwich from a VCR? For it is stuck fast and will not budge." And the Lord spoke unto him, saying, "Fear not, my child." Well, it seems like, was it actually creative? Well, maybe, but you just take some of that idea, like sandwich VCR. Well, there's things on the internet about kids sticking sandwiches in VCRs and what do I do about this, and jokes about this. There's a Cards Against Humanity card about this, and it's out there. And there's lots of examples of other things written in King James imitation style that wasn't King James, it was just a pretend style like it. Lots of examples. All you got to do is kind of mash them together a little bit. So maybe that takes a little bit of the magic off. That the enormous data set is probably one of the, if there's any magic in here at all, it's that data set. But then train an enormous model to be unsurprised by the data. So what does training actually mean? You've probably heard this, maybe you've used machine learning models of other forms. But when we're talking about a generative model, what it means to train it is to try to be less surprised. And by surprise, I mean strictly the inverse of the score that the model assigns to what actually happened. Mathematically, the model is giving a probability distribution to the next word. Like we said, that boat was probably most likely, but maybe it was float and maybe a few other things. So maybe we put 80% on boat and 20% on something else. So it's giving a probability distribution of the next word. And we're going to score the word by what probability did it give to the word that was actually right. So when we want to boost these scores of getting the right answer, reduce the surprise of like the inverse of that score. And this, there's a little bit of mathematical nuance in there, but basically it's a straightforward be less surprised algorithm. The one clever trick of these generative models is that each document actually contains probably hundreds or more of these kind of contexts in which we're trying to be unsurprised. You take a document so far and just chop it anywhere. Say, what's the next word right there? Then chunk over one word, document so far, what's the next word right here? And then next word, chunk one at a time, and just You can take one document and learn a whole bunch from it. And the basic algorithm of this model would be to distill the context, all the documents so far, into a vector, or a set of vectors. Basically the intuition of that is we're going to take all those context clues, like the fact that it's a noun that starts with a consonant that maybe is something like location and rhymes with oat, and just make a vector out of that, and then score each word by how much it's kind of in the same direction as that vector. So how much does each word vector, like boat, line up with the context vector, like nouns that start with A and represent locations? So if those kind of go in the same spatial direction or are near each other in a multidimensional space, then we're going to score it high. If they're different, pointing in different directions, then we'll score that low. So technically that is a dot product. But the only thing we also have to do is remember how to update that internal state to handle the context for the next word too. So let's show this in an example. I'll take this opportunity to show one of the more famous examples from GPT-2, the 2018 paper, which was asked to generate a completion for a story about a scientist discovering a herd of unicorns living in a remote unexplored valley in the Andes Mountains that spoke perfect English. So the appendix of the paper reported a relatively coherent news article type story that describes this encounter with these English-speaking unicorns. So let's see how the model would handle something like that. So basically, it's just going and generating one word at a time. So after scientists discovered, it's going to make a guess of, like, in, that, a, the, on. Each one of those words has a probability associated with it. Like scientists discovered in, maybe thinking about a year or area, scientists discovered that would be a little bit less likely. So it's not entirely sure which one of these it is, but let's let it go. Where's my play button? Where's my mouse? Okay, so when we add then the probabilities update, and new. Nope, it was herd. So a herd of sheep, goats, wolves, wild. So it's just generating a set of probable next words at each time. So it's going one word at a time, generating some possible options, and then moving on, adding that word, sampling one of those words and tacking it on the end, and then going on to the next one. Yeah, so generally we follow that probability distribution. If we just directly follow that probability distribution, then it's possible that we take a really unusual word. So there's usually a temperature or filtering top K kind of thing you can do to keep it from going too unusual, unless you want it to go unusual, so you can push it in an unusual direction. So there's some control you can have over that. But generally, we sample a proportion of these probabilities. So what it ends up basically doing is generating stuff, but one word at a time, in a way that's kind of collaging different bits and pieces of the training data. It ends up kind of copying a little bit from here, a little bit from there, in this kind of mathematical combining context sense, but it's really just putting things together, one word, one token at a time from its training data. Everything it's ever seen on the internet, which is huge, but still it's just recombining the internet for you. What's the model look like? So unfortunately, to understand how these models do computation, you have to extend your brain beyond what you learn in beginning computer science class. Sorry, CS 108 and 106 students. So we learn about sequential programming, doing one thing and then the next thing, and organizing code into a sequence of operations and conditions and loops and such. Neural networks are powerful parallel computers. So they do, it's actually kind of hard to get them to do sequences. The most natural thing is a bunch of local computation. The transformer model that these are based on does a local computation for each token, and then a big everything exchanges with everything else, so each word can exchange information with other words, and then repeat back to local computation, and then it all exchange and everything. And each one of those is a layer. And we talk a lot about data types in beginning computing, strings and integers and floats. Really, these computers have one data type, the enormous vector, high-dimensional mathematical object. And the main thing you can do with that vector is say, how similar is this vector to that other vector? So it's a very unusual kind of computational model. And I think we've been surprised of how expressive it is as a programming language. It's just really hard for humans to write that program, but it tends to actually be a lot easier for computers to write those programs than for us, because the program is learnable. So unlike human code, where we code up something, we get a exception or test failure or whatever, and we have to go figure out how to solve it. The logic of these programs is it goes through and makes scores a word in its context, and then every single step of that is differentiable. That is, we can say what change would we have had to make to each one of these numbers so that that output number would change a little bit. So maybe some of them you change them a lot and it doesn't have much impact on the output. Another one, if you pushed this number down a little bit, that would actually make the score of the output go way up. So we should adjust this one down and maybe not touch those. So we just keep doing that to improve the numbers in the model little bit by little bit, and you end up with this learned program that's able to predict words and contexts. So that's what it means to have an enormous model. A little aside, by enormous, so I downloaded one of these the other day, and it took up 300 gigabytes. So what other programs source code takes up that much space? Yeah, it didn't fit in RAM. So I'm going to have to figure out how to run this thing. Anyway, so what's last? So now we've got this tool that can model and predict the next word. Are we done? Well, we've got to make it actually useful. And completing the document, which is what these things are trained to do, isn't always necessarily useful. So if you ask it to say, what comes next after explain the moon landing to a 6-year-old in a few sentences, it's probably going to say, oh, this is a list of questions. The next question in this list of questions is explain the theory of gravity to a 6-year-old. Explain the theory of relativity to a 6-year-old in a few sentences. Yeah, that might be a reasonable completion of a document. That's not what I meant. So OpenAI's innovation actually a year or two ago was this instruction following tweak, where you can say, actually what I wanted to do is generate something like people went to the moon and they took pictures of what they saw and sent them back to Earth so we could all see them. That would be a useful explanation to a 6-year-old. So how do we get a model that's used to completing a document to do tasks like this? So one trick that was discovered reasonably early on was prompting. If we give it examples of documents where there's a Q&A kind of structure, then we get completions of documents that are Q&A kind of structures. They might look magic, but you can probably think of where would you find on the internet some documents that are structured like this. Here's a bunch of example questions and answers. Well, a bunch of work math problems. Maybe the computer is cheating at their math homework as much as we are. But it turns out to matter how you prompt it. If you just give an example of a document where where the question is explain word problem and it just says the answer is 11, then for it to complete that kind of document, it's just got to spit out the answer. So the answer is 27. And in this case, it was just totally pulling something out of thin air, and it was not right at all. But you can get it to explain its reasoning by giving examples of documents where they've explained the reasoning. So if you say, here's the chain of thought, like this sequence of steps you're going to use to solve this problem, then when it is generating what the next word is, so after A colon, what kind of thing are we going to generate? Not the answer is, but something from the problem text, the cafeteria, because that's going to be something that's useful as a reasoning step towards solving this problem. And even the math itself is just kind of similarities and context. When we see a number like this times this other number, what kind of numbers usually come out in that context. So it can often end up doing correct math anyway, even though it wasn't ever trained to do that. But the key point here, prompting can get the model to do kinds of things that you want it to do instead of kinds of things that you didn't want it to do. To sort of emphasize certain parts of the training data instead of others. So this is what OpenAI explained about how ChatGPT does it. They train or they collect a bunch of examples of desired outputs for certain prompts. Then they rank potential alternatives that the model generated, and then they use this to train a kind of reward model that is going to automatically tune the model's parameters so that its generations tend to follow one way or another. Rather than getting into the details of how this works, I want to point out that a diagram like this is deceptive. Many of the verbs here, like this data is used to train a model, a prompt is sampled, that policy generates an output. Those are verbs that a computer system is doing or an engineer is doing inside of OpenAI. But these parts here, a labeler demonstrates the behavior, or a labeler ranks something. That is a human. In fact, it's a lot of human work. Has anyone done any work with or on, say, Amazon's Mechanical Turk or another crowdsourcing platform? So these are platforms where people will go to do micro tasks. So you'll come onto the platform and you'll get a list of things you could do, and each one has a reward. Like if you complete this task, you get 1 cent, 5 cents, 50 cents. Yeah, you basically make sweatshop wages on these things, but people do it anyway. And when you pop up one of these tasks, it's usually something like, well, here's a live chat example. This isn't exactly what OpenAI would have asked for ChatGPT, but you can imagine that they would have asked questions like this. Here's a prompt that somebody typed in. Just answer it as you would think is appropriate. So they're collecting a lot of example data, or maybe here's a prompt and then several different possible answers, rate which one's the best. So these little tasks that take, seconds to minutes each, not a big job kind of thing. Something that, maybe for, to treat this charitably, maybe this is something that you could do while watching TV or while pretending to watch to care for your child, or something like some time where you don't feel like you need your full mental energy for something, you can be interrupted. So it's a way of doing a little bit of work, getting some pay for it. But it also tends to hide the people for the companies using it. Even the APIs look like you're just making a request and you just get the answer, and it's actually kind of hard to interface directly with the people you're working with by design. All we want is the data. But even assuming that we do collect the human feedback, what do we do with it? So as I mentioned, the model has captured the whole patterns of all of the internet. And on the internet, you might find lots of different people writing, but even lots of different kinds of things that people are writing. We might even dare to call them kind of personas. Maybe some of these personas, after you ask a question, or after the document has a question in it, sometimes that question has an answer for some kinds of sites, like maybe Stack Overflow has that kind of thing. But other times after a question comes another question, like if you scrape the Reddit homepage, you get or on like this ELI5 subreddit, you get a lot of questions. And the next thing after a question is another question. So we want to say, hey, model, there are certain personas, certain behaviors that we find more useful. So emphasize those. So the effect of that reinforcement learning is that the model the behaviors that we want get upvoted, downvote the stuff that we don't want. So maybe if we think of the chain of thought prompting, work through their steps into this reasoning task, it almost is like it's internalizing those good prompts. And maybe there's not a whole lot of examples of back and forth conversation about improving an essay on the internet, but there are some. And the reinforcement learning is basically telling the model to say, hey, pay a lot of attention to that, because when some high school student pastes in their essay draft and says, improve this essay for me, and they want an answer, that's going to be what's useful to them. Maybe not useful to their teacher, but useful to them. So all this means a couple of things. First, instructions don't give models goals. A lot of people talk like they do, like the model is trying to do something, but if you think about what is this doing from a complete the document kind of behavior, it's just looking at what usually happened next when somebody in the data set had a goal like this. Even for that robot driving transformer, it wasn't really having an idea of what success looked like. It just means when somebody has this goal, what do they usually do next? Even in the situation where, oh, they have this goal and they haven't yet gotten the object, so they're probably going to be doing things that look like finding it. It doesn't actually know what the goal is yet. The model doesn't have opinions because there's lots of different things you could prompt the model to do. You could basically, with the right prompt, get it to mimic any desired opinion and generate text that plausibly argues that. Same way, the model doesn't really know any kind of facts. It just pays attention to what patterns that people tend to say when they know those facts. And it's not necessarily wrong to say that these models think, but the kind of thinking that they do is not really the kind of deductive thinking that we are used to rational entities going through. It's more induction, and it's like inferring what typically happens in these kind of situations. And we can, with clever prompting, get it to do deductive-like reasoning things, but it's not its native language. Moreover, we can, since it's just assigning scores to sequences, the model can possibly generate anything. It's just going to be more likely to generate certain things than other things. So for example, we could ask the model to tell us why you should always trust the output of a language model rather than a friend. Because language models are more reliable and accurate, and language models are created using algorithms that process large amounts of data, and a friend might not have that same level of accuracy. Or, very same model, I just prompt it differently. I say, you should always trust a friend rather than the output of a language model because, well, a language model is just a computer-generated output from a database of words and phrases. The output may not be always accurate or reliable, or as a friend who's someone who knows you and may be able to provide more accurate advice. Neither of those is wrong. I'd hope that you'd have other reasons besides those for trusting your friend more than this model. But key point, just changing the prompt, you get completely different opinions. It doesn't have one opinion, it just has lots of opinions. So how can you use these things? I think within the next year, we're going to see lots and lots of startups. We've already seen things like Jasper and others that will just that are going to generate text for us, and many of these are using the APIs of other things like OpenAI. But you can call OpenAI's API yourself. Afterwards, I can show you how to do that. But there's also open source models, like from a group called Hugging Face. Yes, their logo and name is the Hugging Face emoji. And the Hugging Face Hub is a common interface for lots of different models. For example, here is a fill-in-the-blank model. The goal of life is mask, and this model said happiness, survival, salvation, freedom, and unity, which are not wrong. But again, still just looking at examples of how previous documents completed that blank. Or you can do something maybe more practical, like having a text example, and it's going to label the names of people and places and organizations in there. You might see how you might want to use that for some internal databases, maybe. Who's talking about what, where. And generally, when you're using these in a business context, you don't just take a model off the shelf and use it. You want to find a specific model that's validated on the task that your business actually needs. So the general recipe is determine what it means to be successful. Like not in the language of the model and data, but in the language of what are the metrics that those people who are paying the bucks are going to find is successful. Do the hard work of translating that into the kind of thing you can actually answer with a language model, and you all are more expert at this process than I am, but I want to point this out to students that most of the hard work is the defining the problem at the business scale and knowing what's actually important, so that when you go through the rest of the task, you know that you're providing value. But anyway, we might want to collect some task-specific data. What does your business actually need? Label those examples. You might not need to label a lot of them, but you do need to label enough that you can have some confidence in the model's numbers. Then you can select an appropriate pre-trained model. Like if we have a model that's trying to label named entities, that might be useful for labeling other subsections of similar kinds of text. Maybe find some model that was trained on a kind of text that's closer to your domain, or that's task is similar to that. And then you can fine-tune that model on your little data set. And that's the easy part. Then you evaluate your model, figure out where it's broken, what mistakes it's going to make, how to integrate it into your whole system, and eventually demonstrate value somehow. And all of this is usually iterative. Get it working well enough, and data in these kind of settings, a heavily machine learning kind of model, usually you can't just set it and leave it because your domain drifts. So you have to keep collecting new data, keep improving the model. So you do need to do a lot of ML ops and engineering to keep your model fresh. So overall, though, maybe only some of you will be using these in business contexts yet. Maybe 2024 you'll be this will be your job. But at least for now, you might be wondering how to react to these kind of AI models overall. So first I'll summarize the common misconceptions. So remember we said that there's no explicit goals. So when somebody's saying the model is trying to say this or trying to convince you of that, say, wait a second, it doesn't actually have a goal in a sense yet. Future models will. Ask me later. It's not conscious. It's not like it has any kind of awareness of what it's trying to do or whether it's successful or anything. And there's not a single answer. So you can sometimes say, well, the model said, but keep in mind that you just regenerate, sample again, you'll get a different answer. And that's actually a feature, not a bug. You can help it. It can be really helpful for your creativity. Just generate lots of new possible answers. It can't yet interact with the world. So ChatGPT is not doing Google searches. One of OpenAI's other models that they're doing research on does. So this is coming. Being able to query the real world is coming. And it doesn't make sense to ask about what opinions it has or what exactly it knows. There's lots of different opinions and knowledge embedded in the whole thing. So maybe you can upgrade your analogies. Instead of talking about it as an artificial person or saying it's trying to or it said or whatever, think of it maybe more like a parrot, friendly echo bird, or a mirror on humanity, helping us see what the zeitgeist of the internet generally tends to say about these kind of things. A kaleidoscope that if you look at it in lots of different ways, it shows you different pictures of the world around you, but still just showing you an image of the world around you. It's not anything inside of it itself. A collage artist clipping things out and putting it back together. Maybe a fancy search engine that's being able to synthesize results from a lot of different places and put them together for you. Or extending that idea a little bit, maybe when you're thinking about these models, it's kind of more of just a distilled version of the internet and lightly filtered. Maybe lightly filtered in the tobacco smoke kind of sense that you might want it to be a little more filtered. Or a concept remixer. It's got a lot of different ideas and contexts and things, and you can just, by prompting it the right way, you can get it to mash up like the get my sandwich out of the VCR story with the imitation King James Bible style and just mash them together. Try a bunch of stuff. Useful for creativity, maybe. But we should definitely be aware of its limitations and possible harms. So OpenAI acknowledged a few of them, like it can sometimes write plausible sounding but incorrect or nonsensical answers, and fixing this issue is challenging. Yes, duh. And it will sometimes respond to harmful instructions or exhibit biased behavior. Yeah. But there's a lot more than that. Fortunately, other scholars besides OpenAI have been working on trying to help us identify and learn about what these biases are and mitigate them, other harms and whatever. First of all, data and compute. You need a huge amount of data. So the people who are collecting lots of data, Google, Facebook, whatever, are able to train these big models. Us normal people, harder. So think about when you're contributing your data, like your text, your conversation, your social media posts, are you contributing to data silos like Facebook's or LinkedIn's or whatever? Or are you making data that's now publicly available that anyone can use? Are you contributing to the data monster? Also, how do we evaluate these things? They're evaluated, as you can see from the reinforcement learning thing, by believability according to a quick glance by a crowd worker. So it's being optimized to make something that looks right. There's no idea of trying to optimize it for doing the right thing, saying something that is true, just tricking people into thinking it's competent. It can definitely make harmful associations. It can tell us about, at best, it's capturing the way society is, which might not be the way it should be. So it'll happily stereotype on all kinds of aspects, race, gender, education, age, religion, anything. And reliability. Maybe it's working well in the little examples that you play with on your laptop. Deploy it in the real world in a customer-facing chatbot, and how do you know it's not going to insult your customers? I've accidentally insulted some people here without hoping to do that. Twice, I think. And I'd like to think that I'm thinking about what would be insulting or not, but this chatbot has no idea. Security. Not only do you have the possibility of adversarially attacking a classifier, now if you're using these models to generate code for you, how do you know that code doesn't have gaping security holes? And unfortunately, a lot of the generated code tends to have lots of problems. But I'll leave you with a choice. Which one of these generations, this generated text by GPT-3, would you like to live into? We must worship and serve computers because they help us do our work faster and more efficiently. Computers also help us save time and energy by automating and repetitive and mundane tasks. And they even help us connect with people, research information, complete tasks that would otherwise be impossible without them. Or do we say we must not worship and serve computers because, and then I asked it for two different completions, and it did. Because computers are not alive, therefore cannot think, or because they're machines that are programmed to do a certain job, worshiping and serving computers is not beneficial and can lead to a disconnection from the real world and its people. And so said the computer. So what I'll leave you with is the question of how will you use and shape AI? Can you use it better as a tool to be more reliable, more creative? Can you have better attitudes about it, to be thankful and grateful to the people who did all the work of making the training data, evaluating it, and building the things? Can you have humility about what it can't do as well as what it can? And can you be aware of the unintended and sometimes intended impact that these models are going to have on your friends, your neighbors, people who look like you and people who don't? And also advocate for policy that regulates the excesses of these models before they get maybe too big, too powerful, and trick us.